Hello and welcome to Tensar Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. Well, here we are in Singapore, right outside the famous Raffles Hotel, named after the founder of Singapore 200 years ago, and the original hotel was built a bit later in 1887. What's the address of the hotel? Number 1 Beach Road. But where's the beach, Brian? The tide seems to go out a long way. In fact, I've been told that the coastline is now beyond where that tall grey building is. Over 2 kilometres from this point here. So this used to be by the beach, this hotel and this road, but now the coastline is over 2 kilometres away, and that's due to land reclamation. So that gives me an excuse to talk to you about the geotechnical aspects of land reclamation. So imagine you want to extend the coastline of your country, or you want to build an artificial island. How do you go about it? Well, you need to obtain the material. Quite a lot of the reclamation in Singapore was performed using hills inland and taking that quarried material out to sea, but more commonly it's dredged material. Ideally it's a sand, but you can use clay, but the construction process is a bit more difficult. So you would bring it to your site by a dredger, and you'd use a wonderfully named bottom dump dredger to open the doors at the bottom of the boat to drop that slug of material on the sea floor. As you get nearer to the surface, then you need a pump discharge, and you can bring the level up to the water surface and a few meters above, depending on the requirements. But of course that's putting a huge weight on the sea floor, so you're going to get very large settlements, and in low permeability soils that's going to take a very long time. So for those reasons, development normally comes years after the reclamation has actually taken place. But you can speed it up with PVDs, prefabricated vertical drains, to shorten the drainage path times. You can also reduce the settlement during development by using preloading. So you can put additional fill during the consolidation process, and then when the consolidation is complete, remove that fill so that the reclaimed land is now over consolidated and will settle less. If you don't have spare fill material, you can use vacuum preloading to get the same effect. But in earthquake zones, you've still got the risk that you've got sometimes a fine sand in a relatively loose state in saturated ground conditions. If there's an earthquake, those are perfect conditions for liquefaction, which would be disastrous. So you need to assess the liquefaction potential. That's normally done by CPTs. You can assess the liquefaction potential for those, and if necessary, do some remediation works, and then do post-treatment CPTs to check that you have reduced the liquefaction potential down to a suitable level. And suitable remediation measures include dynamic compaction, that is dropping a huge weight from a great height, slamming it down on the ground surface and compacting it that way. Or there's vibro compaction, where you insert a vibro float into the ground with vibration and adding aggregate to compact the land that way. Or there are rammed aggregate piers. So you are compacting, ramming aggregate into the material, thereby creating high density aggregate piers and compacting the soil around and preventing liquefaction and reducing settlement that way. That's all for this episode of Tensar Ground Coffee. We're off there for a Singapore sling in the Raffles Hotel, so thanks for watching and see you next time.